My name is Gleason, and I will be presenting Twitter Ally, a browser extension to make Twitter images accessible. This work was published as part of the CHI 2020 proceedings. People with vision impairments are being excluded from social networks such as Facebook, Twitter, and Instagram because these networks now have a lot of visual content like images and videos. We need to figure out a way for these social media images to be made accessible. This image here could be described as Pittsburgh bus teetering on the edge of a giant pothole. Three police officers look on, one with hands on head. However, someone with a vision impairment who's using a screen reader to go through Twitter might only encounter the word image because no one added a description of the visual content. This happens a lot, and it means that people with vision impairments miss out on the cultural context of images that are posted on social media and any memes or surrounding discourse. We have found that Twitter is not very accessible as a whole. Only 0.1% of all images have alternative text. This might be a bit higher for celebrities or politicians, but blind users are probably seeing less than 5% of images in their feeds with accessible descriptions. We have developed Twitter Ally, which is a browser extension, to make this content accessible. What methods can we use to make alt text? We looked at 6 of them, and I will give an example of each. Whenever someone shares a link on a site like Twitter, there's often a URL preview that is included with the social media post. This is a common source of images. One thing we do is get information from the linked web page, which is called URL following. It looks for alt text for that same picture on the linked web page. For example, in this photo it found, "Mist rises off the water as a flooded building is pictured after Hurricane Matthew passes in Lumberton, North Carolina." Photo by Carlo Allegri, Reuters. Many people with vision impairments like to use text recognition software to discover text in images. In this image, text recognition would have found the text, "This is not about partisan politics, it's about upholding the institutions that make our democracy work." President Obama. Note that the quotation marks in the image were mistakenly recognized as 66 and 99. On Twitter specifically, sometimes people post screenshots of other people's tweets instead of using the retweet feature. So Twitter Ally also attempts to use the Twitter API to find that specific tweet using search. Twitter Ally found the text for this tweet: "Alabama will not see any impacts from Dorian. We repeat, no impacts from Hurricane Dorian will be felt across Alabama. The system will remain too far east." We also use automatic captioning, which uses a deep learning neural network to produce a image caption from the image. This image, for example, it gives the caption "Janelle Monáe wearing a suit and tie." We re-implemented the Caption Crawler project, which was a project to reuse alternative text from around the web. It performs a reverse image search to find the same image on the web, and then it takes one of the alt texts to find for that image. This image would have said, "People pouring seawater on salt field during sunset." And finally, we have crowdsourcing. I hired workers in real time to write image descriptions for photos. For this image, we might get the text a blue graphic, like a trading card. It has an image of 2 men playing ice hockey with the words "after 40" written up the side. It has the score 0 next to the Toronto Maple Leafs logo and 1 next to the Pittsburgh Penguins logo. So I took these 6 methods and designed and packaged them into one tool called Twitter Ally. The user installs a browser extension. Then as they scroll, it requests alt text for images in their Twitter feed. It tries 6 methods in order, with crowdsourcing being last. If any of these methods meet their own quality thresholds, Twitter Ally will take the alt text and return it early without progressing to the subsequent methods. This progression was chosen to optimize speed and cost. To analyze how often Twitter Ally produces alt text for a sample of images, I recreated the timelines for 50 blind users for a day. I sampled 50 tweets from each user for a total of 2,500 tweets. A little less than half of these contained images, resulting in 1,200 images or URL previews. Of these images, 7.6% of them already contain some sort of alternative text. Twitter Ally was able to increase this to 78.5%, approximately a 70-point increase, and then crowdsource the remainder to ensure every image received alt text. If we evaluate on different metrics, automatic image captioning provided the most alt text for images and was able to provide alt text for images that other methods could not handle. Text recognition also produced many high-quality descriptions relative to the amount of money it costs to use these external services. In prior work, we have measured alt text quality on a 4-point scale, with the first point being irrelevant to image, second somewhat relevant to image, third is good, some aspects of the image are described, and fourth is great. Almost everything is described. So I, along with another researcher, rated the quality for a sample from each method. Crowdsourcing had the most high-quality responses and the most great responses. Note that in this chart, the higher quality are on top, lower quality on bottom, and they're ordered with great and good combined. Next, text recognition was pretty close, with less great alt text. The original alt text written by posters was fairly good, with great alt text between crowdsourcing and text recognition. Automatic captioning has a lot of good, but not a lot of great quality, indicating serious room for improvement. The other methods, Caption Crawler and URL following, both reused alt text from around the web and had low quality alt text. Tweet matching never came up, as screenshots of tweets are pretty rare. 10 screen reader users used Twitter Ally for 1 week and for at least 10 minutes a day, but often more. We asked them in interviews beforehand about their experience on Twitter. They estimated that 50% of their timeline is images and 12% had alt text on average. 8 out of 10 said inaccessible images affects their decision to follow an account. Through the deployment, over 3,500 images were collected, and 2% were accessible before using Twitter Ally. Participants reported that they preferred text recognition and automatic captioning methods because they were quick and often fairly descriptive. They said that the crowdsourced descriptions were accurate, but it was too slow to wait for someone when browsing social media. Participant 4 demonstrated that the usefulness of a particular method is dependent on the timeline contents, saying that text recognition is one of the most useful because a lot of my timeline is tech and geek stuff, which often has screenshots. Text recognition is key to understanding what is going on. Participants repeatedly emphasized the distinction between accessibility and accommodation. I like this distinction from the University of Iowa. Accessible technology is designed for use by the greatest number of people, including people with disabilities, and doesn't require adaptation. Accommodations are patches or fixes, applied retroactively to overcome barriers in the environment or system. Twitter Ally is a good accommodation, but doesn't replace authors writing their own alt text. Often authors are the only ones with enough context to write good descriptions, such as names, pronouns, places, or temporal context. Participants wanted Twitter Ally to inform users that their content was inaccessible and try to convert them into writing their own alt text. So to summarize our findings, crowdsourcing is a great method, but it's just slow and costly. Automated methods, like text recognition or automatic image captioning, are quick and cheap, whereas alt text reuse methods like Caption Crawler or URL following was unable to find good quality alt text on the internet. Overall, Twitter Ally is able to increase accessibility of images on Twitter to about 80% before crowdsourcing. The majority are high quality. I would recommend that platforms such as Twitter emphasize user-posted descriptions. These are likely to be more accurate due to additional context held by those users. Automatic methods that are robust or clearly succeed or fail should be deployed widely. This is text recognition. Automatic image captions should be made available, but we need to recognize that they are not perfect. Prior work has shown that they can be confusing. If you would like to give Twitter Ally a try, you can download it from the Chrome Web Store or visit bit.ly/Twitter-A11y. Thank you for your interest in Twitter Ally. You can email any questions to cgleason@cs.cmu.edu.